Okay, so today our focus is going to be measurement and unit conversions. I want somebody to talk me through what unit conversions even means. What does that concept even mean of unit conversions? Yeah.
Where you have like one, like it's from centimeters,
Mm-hmm.
and one changes into like millimeters or
Perfect.
like that.
Perfect. So it's when you take one unit and you convert it to a different unit. So if I said 6 inches, how many feet is that? 6 inches is 0.5. It's a half of a foot, right? Do we agree with that? 6 inches is half a foot. 5,280 feet is how many miles? 1 mile, right? That is a unit conversion. That's as simple as they get. They get a little bit more complicated, but that's what they mean. And so I don't want this term of unit conversions to be like mind-boggling for you. All it is taking a measurement in one unit and making it into a different unit. That's what it is. Okay? So we're going to focus today on metric system. So our boarders should be happy. We're talking about the metric system. Are we familiar with the metric system? Meters and centimeters and liters. Yes? Does that sound familiar? That's how you measure things, I think. In meters? Do you measure things in miles? You measure things in miles or meters? Meters. Okay, so meters should feel comfortable to you. American students will be much less familiar with the metric system. All right, so here we go. I'm going to give you what I call the base units. And base units are basically the most commonly used units for these types of measurements. I say 7, but I actually took away a couple, so there's really only 5. I need to change that. Okay? The most common way that scientists measure length is in meters. And it's abbreviated with just an M, a lowercase m. That's important. Lowercase m. Okay, what do Americans usually measure length in?
Inches.
Right, we already said like 3 different answers. Inches, feet. American system of measurement is out of its mind, right? It has 5 names for everything. Okay, so the way that they, in the scientific world or in every other part of the world, basically measures length is meter. And then units derive their size based on a prefix from that. Centimeter, millimeter, kilometer, right? Those are different derivations of that meter length. But meter is the base. The most common way we measure mass is kilogram. Okay, kilogram. I want you to make sure you understand that gram tells us that it is a mass unit. Kilo is a prefix that we attach to it. So why would kilogram be the base unit for mass instead of just regular grams? Any ideas?
Isn't kilo smaller than
Opposite. A gram is 1,000. There are 1,000 grams in a kilogram. Okay, and so most things that we measure are going to weigh more than 1,000 grams. So rather than have to report all of our measurements as 12,000 grams, we would say it's 12 kilograms. Okay, so it just gives us a more palatable number, I guess, to give our measurements in. Rather than report everything in the thousands for grams, we would just say it's 12 kilograms or 5 kilograms or whatever it happens to be. Okay, so I want you to understand that gram is the mass unit, but kilogram is what we call the base unit because it's the most commonly used. Kilo is still the prefix that's attached to gram. Does that make sense? So we could also have regular grams. We could have centigrams, milligrams, or whatever it happens to be. Okay. Base unit for time is the seconds. Base unit for time is seconds. So we don't usually report things in seconds in the United States when we talk about time, right? We usually are dealing with longer periods of time in which we would report minutes or hours. But seconds is the most common measurement. Okay, Kelvin is the most common temperature unit. In America, what do we use to report temperature? Fahrenheit, right? Does anyone else in the world use that? No. Everyone else in the world uses Celsius, right? Degrees Celsius. And so degrees Celsius and Kelvin have the same unit, what do I want to say, ratio, okay? So if the temperature increases by 1 degree Celsius, it also increases by 1 Kelvin. Okay, but if we increase 1 degree Fahrenheit, we do not necessarily increase 1 degree Celsius. So Fahrenheit, we don't ever deal with in this class, like ever, right? Scientists never deal in Fahrenheit. They deal in Celsius. So why is it important that we as scientists know how to communicate with the metric system? Why is that important?
So we can communicate with other people.
Perfect. So that we as Americans can communicate with other scientists, right? If we would report scientific findings in inches or pounds, other people would be like, what? Okay, they wouldn't know what sizes those things are. And so it's important for us to be able to communicate scientific measurements with the metric system. Okay, last thing is called a mole. How many of you have heard of not an animal mole, but moles in scientific lingo? Okay.
Not at all.
A mole is actually an amount of substance. Moles is an amount of substance. And so what that looks like is, you don't have to write this part down, but I just want you to listen through this for a second. 1 mole of any substance, we're going to get to this later in the semester, but 1 mole of any substance is, let me write down the number so you can see how big it is. 6.022 times 10 to the 23rd of any substance. Have you seen that number before?
Yeah.
Call Avogadro's number. Okay. Avogadro's number represents the amount of anything in 1 mole. So if I have a mole of roses, I have that many roses, right? Wouldn't even fit in this room. But a mole of hydrogen atoms, 6.02 times 10 to the 23rd hydrogen atoms weighs 1 gram. Okay, so the amount of substance in terms of moles is always this value. It just gives us like a big way to describe things. It's like a dozen, right? How many things are always in a dozen? 12, right? Okay, yes, eggs. Right? If I say a dozen eggs, I know I'm talking about 12 eggs. Moles is the same thing. If I say half a dozen, how many things am I talking about? 6, right? So I could say half a mole or a third of a mole or whatever. It's just representing a much larger quantity. That's the only difference. Does that make sense? So a mole of anything is this many of the thing.
So,
right?
why don't you just write like the actual number?
Because it would take 6.022, 4, 5, 6. I have it printed and ready for you. We're going to use this a lot, so please do not lose this. Okay, don't lose it.
Are we going to use it on the test?
I'm not sure yet. I'll think about it.
That's essential.
I used to have those, that game where you put a bug in a maze and you run around the maze and you have to get out of it. I used to have all those in a book. I have them in my home.
Okay, in the metric prefixes system, the prefixes can be attached to any unit. Any unit, any metric unit can have these prefixes attached, and it's super important. Okay, in all of the examples, I used meters. Okay, I use meters. I could have also used grams or liters or seconds, okay, or moles, even though we don't really use that. Okay, I could have used any of those other things. So that's a really important thing for you to wrap your mind around. Okay, the way I ordered this chart, and this is important too, is that I told how many of the smaller unit are in the bigger one. So a mega meter, for example, is 1 times 10 to the 6th, or 1,000,000 meters. A megameter is 1 times 10 to the 6th of the smaller unit. Okay, the same thing would be true if I said grams. I could say 1 megagram is equal to 1 times 10 to the 6th grams. right? The same would be true for liters or seconds or whatever else I'm using. Okay, does that part make sense? The prefixes apply to all types of units. So then I say to kilo. Kilo is one that you'll really need to have memorized. Kilo means 1,000. So there are 1,000 of the small units in the bigger unit. Okay, 1,000 of the smaller one in kilo. Then comes what we call the base unit. And I don't want you to get that confused with the most common measurement base unit. But base unit is just the thing by itself. Meters, grams, liters, whatever. Okay, that's where the base is. That's the middleman. From underneath there, I would say that 1 meter is 10 decimeters. 1 meter is 100 centimeters. 1,000 milli. 1,000,000 of micro and 1 billion nano. Okay, so those are prefixes that you'll need to kind of have memorized. Okay, you'll need to have memorized. Stand some. Questions about how we use this chart? Okay. All right, here we go. Other units I want you to be aware of. Yeah, these go in your notes, and then I have another chart for you on the back that you'll use in just a second. Okay, other units I want you to be aware of. We said volume is measured in liters, which by extension means that milliliters can measure volume also. This is a conversion factor that I kind of want you to be aware of, or I want you to have heard at least. 1 milliliter is equal to the same as a centimeter cubed, right? Any unit, any length unit that's cubed automatically makes it a volume unit because volume is measured length times width times height. Right? That's a cubed unit. So a volume unit can be either milliliters or centimeters cubed. They mean the same thing. So a lot of times you'll see density written as 1 gram per milliliter, or you could see it as 1 gram per centimeter cubed. I think a lot on your infographics, you saw this centimeter cubed unit. Right? These two mean the exact same thing. Okay, so a milliliter is the same amount of substance as a cubic centimeter. In hospitals or medical situations, have you ever heard somebody say, I need 50 cc's of something? Yeah. Have you heard that term before? Right? I watch a lot of Grey's Anatomy. Okay, so they say that a lot. I need so many cc's. Okay, so cc's means cubic centimeters. That's really all it means, cubic centimeters. So they're saying I need 50 milliliters of something. Which one's faster, 50 cc's or 50 milliliters? Cc's. Right, cc's is faster. So it's just a way of speech. Okay, that cubic centimeters, you'll hear it say cc. So now when you hear that, you can inform your family a little tidbit while you're watching Grey's. All right, temperature is degrees Celsius. I'm going to teach you how to convert from Celsius to Kelvin and back, okay, and backward. If I needed to go from degrees Celsius to Kelvin, anybody know the conversion? I add 273. I add 273 if I want to go from Celsius to Kelvin. So what that means is 0 degrees Celsius equals how many Kelvin? Right, 273. So water freezes at 273 273 Kelvin.
So Celsius is Kelvin.
Celsius has the same ratio as Kelvin, but it does not mean the same thing.
Okay, so
Kelvin is like the absolute way to measure temperature. Does anyone know what happens when we get to 0 Kelvin? Anyone know what that's called? If we would get to 0 Kelvin, that means we are at negative 273 degrees Celsius. Okay? What happens if we reach that point? We cease to exist. This is called absolute zero. Absolute zero, write that down. Absolute zero is 0 to Kelvin.
So you can...
No, everything... Every molecule in the universe would cease to move. It would stop moving. It'd be so cold, there'd be no energy for any molecules to vibrate. Dunzo. No.
Yeah.
So even if like
They have only approached 0 Kelvin in a very like tight lab scenario, right? They've approached it in like a tiny little thing, but they haven't gotten all the way there. Okay.
So even if the sun like were to blow up.
Yeah, I don't know what would happen if that happened. But 0 Kelvin would be bad for us. That's what I do know. Okay, 0 Kelvin means everything ceased to exist. So if I wanted to go from Celsius to Kelvin, I add 273. If I wanted to go back from Kelvin to Celsius, what do? I subtract, right? That's it. 273. Okay, that number is something that you need to know. Okay, so if I say something is 400 Kelvin, what is that temperature in degrees Celsius? Get out your calculator if you don't have it already. Equals 127 degrees Celsius. Okay, we just subtracted 273 there. Okay, here's something that you should note, and this is like a small thing, but it's not a small thing. You see how degrees Celsius has the degrees sign? But Kelvin does not? Right? It's not because I just forgot it. Kelvin is just called Kelvin. It's not degrees Kelvin. I don't know why. Right? I don't make the rules. But Kelvin is just Kelvin. So, just so you know. All right, the next chart that I have for you, I gave it to you on the back of your first one, and that is the unit conversions that go from the U.S. system to the metric system. Okay, in every scenario except for 2, I gave the bigger unit the 1. Okay, in every scenario except for 2, I gave the bigger unit the 1. Sorry, did I go past that? Here we go. In every scenario, I gave the bigger unit the 1 with 2 exceptions. Okay, an inch is 2.54 centimeters, an ounce is 28 grams, and a gallon is 3.8 liters. But the other exceptions, I did it that way because that's how I was taught and that's what I memorized, and so that's how I like it. So, I know that a foot is 0.305 meters. Okay, I know meter is the larger unit. Believe me, I get it. But this is just the way that I memorized it. So this is the way that I do it a lot. So I don't want to be I don't want to be doing it one way and showing you another way. So, same thing with pound. 1 pound is 0.45 kilograms. Okay, I know that a kilogram is bigger. A kilogram is about 2.2 pounds. But that's the way that I will have it done in class. So, just some things you need to think about there. Okay? We're going to practice a couple conversions to start, but before we do, I want to talk about why do we use units? Okay, why do we use units? Keeping units throughout the whole problem is super important, okay, because it shows us what was measured. Okay, without units, measurements are just numbers. Right? They're just numbers. They don't mean anything. If our number does not have units, then it's just a number. You're just doing a math problem. Okay, so you need to remember that we don't give our answers in plain numbers. We give our answers with units. Super important. We're going to practice a couple conversions in U.S. measurements first, because those are what most of us are familiar with. Okay, just barely most of us. But we're going to practice a couple in U.S. conversions, and then I'm going to show you the system I use to do all unit conversions. Okay. I wanted to look at how we go from inches to miles, and I just want to walk through what we think is a system we would use, and then I'll show you how I like to do that. Okay? If I wanted to go from inches to miles, what's the natural progression for me? To go from inches to what?
Feet.
Inches to feet, and then feet to miles, right? That's the natural progression, which I agree with. If I wanted to convert 36 inches to feet, what would I do? Do I multiply by 12? Or do I divide by 12? I divide by 12. Okay, so I'm going to divide by 12. I need a calculator. Everybody needs a calculator. We're going to do that math for me. Convert from inches to feet. Oh yeah, why did I need a calculator for that? I didn't. Okay. 3 feet. Sorry. I do know how to do some mental math, believe it or not. Okay, now if I wanted to go from feet to miles, I know that 1 mile, and some of you boarders might need to write this down, 1 mile equals 5,280 feet. 1 mile. So if you don't know that conversion, boarders, write that down. Okay? Now if I want to go from feet to miles, what do I need to do? Divide by 5,280 or multiply by 5,280? Divide. Or I should end up with a small amount of miles. Right? 36 is a small fraction of a mile. So now I'm going to take 3 feet divided by 5,280. This one I need a calculator for, believe it or not. Okay, I got 5.68 times 10 to the negative 4th, or 0.000568 miles. Is this answer reasonable? Do we think that is reasonable, either one of these? Were we expecting a big number of miles or a small number of miles? Think about 36 inches and think about how long a mile is. This is a really small part of a mile, right? So we should be expecting a really small part of a mile. Agreed? So that's that system, and I'm going to show you how to kind of streamline that system. Okay? I'm going to skip the second one. We're going to convert now between SI units or metric units. Okay? SI is metric. So we're going to go milligrams to kilograms. And I'm going to show you my system for conversions. Okay? Some of you that are familiar with the metric system can just move the decimal place, and that's fine. But sometimes Americans are not as comfortable with that. Okay? So we're going to show you my system. This is called a T-chart. Okay? So every time I do a conversion, I start with what I know. I start with what I know and I draw a T. Okay, because I want to convert from milligrams to kilograms. Do I know exactly how many milli are in a kilogram? Without doing any math, do I see it on my chart? Do I know how many milligrams are in a kilogram? Do you know? There's 1,000 milli in the base, but we don't know how many milli is in a kilogram. So I need to go from milligrams to grams, then grams to kilograms. Do we agree with that? Okay, so I'm going to go milligrams to grams, then back to kilograms. And so essentially what I'm going to be doing here, I'm going to write this over here and I just want you to watch. If I want to go from milligrams, to grams, I know that there's 1,000 milligrams in 1 gram. So if I want to go from this to grams, I divide by 1,000 milligrams, right? That would be what I would do. So I'm going to show you how to do this all in one take rather than do several different steps. Okay? We said that I want to go from milligrams to grams. So if I want to get rid of something that's in the numerator, I need to put it in the denominator. Do we agree? If I want to reduce something, this is like a big set of fractions being multiplied. If I want to reduce something, they need to be opposite of each other. So I want to go from milligrams to grams. So in my T-chart, what I want to get rid of has to go on the bottom. What I'm going to goes on the top. This is called dimensional analysis, which is a big word for canceling our units. Okay? I want to go from milligrams to grams. So in this section of my T-chart, I have to write down what I know from my chart. I don't do any math until I get to the very end. So I know, is there 1 milligram in 1,000 grams? Check this. Is there 1 milligram in 1,000 grams? No, I'm backwards. You guys will do this. So I want you to make sure you're paying attention. the rule is gram is the bigger unit. It gets the 1, and then we say there are 1,000 milligrams in 1 gram. This vertical part of your T-chart has to be true. You have to be able to say 1 gram is equal to 1,000 milligrams. Okay, does that make sense? This part of your T-chart has to be true. So what has happened is that I've been able to reduce my milligram unit. One's in the numerator, one's in the denominator. So I've crossed it out. And if I stopped now, I'm looking at this fraction, 142 divided by 1,000. That's just what I did here. Okay? But now I can do my next step here. Okay? My next step, I said I needed to go from grams to kilograms. So the same thing has to be true. Does grams get the 1 or kilograms get the 1? Kilograms gets the 1 because it's the bigger unit. How many grams are in a kilogram? 1,000. Okay, so I've canceled my gram unit. I've canceled my milligram units. Since we said these are just fractions being multiplied together, I do that. Okay? I'm left with the unit that I want right here in the top right. That should always be the unit that we want to be in. So the way I do this is I multiply across the whole top, I divide by the whole bottom. Multiply across the whole top, divide by the whole bottom. So get your calculator out. This is exactly how I'll plug it into my calculator. 142.2. Do I need to multiply by 1 twice?
No.
Great. And multiplying by 1 is the same thing. So don't bother plugging that in. In my calculator, there's 2 options. This is how I do it. I go divide by 1,000, divide by 1,000. Okay? And I get 1.422 times 10 to the negative 4th, or that also equals 0.001422. Okay, the second way you could do it in your calculator is 142.2 divided by parentheses 1,000 times 1,000, and you get the same answer. If you are not getting one of these 2 answers in your calculator, raise your hand so I can come help you with that, because this is super important. Convert kilometers to nanometers. Kilometers to nanometers. So first of all, before you do any math, do anything, should you be expecting a really small number or a really big number? I think really big. I think a really big number. A kilometer is this many kilometers is about 3 miles, right? A 5K is like about 3 miles. So if we're talking about nanometers, which is 1 billionth of a meter long, we should be expecting a huge, huge number. Okay? So here we go. We write down what we know. 4.24 kilometers. And what's my natural progression going to be here? Kilometers to meters. So I get rid of kilometers. I go to meters. Okay, which one of them gets the 1 here? Meters or kilometers? Meters gets the 1? Then there's 1,000 kilo in it? No, kilometers gets the 1. And then there are 1,000 meters in a kilometer. Okay, so if I stopped right here and I did the math, my unit would be in meters. But that's not where I want to go. I want to be in nanometers. So I go from meters to nanometers. And I know that in 1 meter there are how many nanometers? 1 times 10 to the 9th. Does everyone understand this scientific notation? What that means?
Yeah.
1 times 10 to the 9th means this. You take a 1 and you move this decimal place 1, 2, 3, 4, 5, 6, 7, 8, 9, and you fill it in with zeros. So that means a billion. Okay, 1 times 10 to the 9th is the same as a billion. So there are a billion nanometers in 1 meter. Okay, so go ahead and do the math. I've canceled meters. I've canceled kilometers. 4.24 times 1,000 times 1 times 10 to the 9th. I get 4.24 times 10 to the 12th. Okay, do you need help plugging in scientific notation in your calculator? Or do you know how to do that? Okay, good talk.